Why, hello there. My name is James, and welcome to this AWS full course. Now, I am supremely, extremely excited to have this course finally live on the channel for a couple of reasons. First, it's super requested, and I've spent an absolutely ungodly length of time perfecting it. But even more important, AWS is a nightmare. It is a headache at the best of times. It can be super obfuscated. There's a good word. Hard to figure out. It can feel absolutely overwhelming. And so I have devised the ultimate gentle and gradual introductory course to AWS, to some of its most popular services, so that by the end of this course, you feel confident and comfortable interacting with the AWS ecosystem, and you can add it as an absolute Ferrari of a skill set to your coding inventory. Now, the way this course is going to work is that I have created a very nifty little backend application that runs on NodeJS. It has an NGINX reverse proxy sitting in front of our application that intercepts the traffic and reroutes it to our application. That's for a little bit of extra security. And it has a PostgreSQL database. So in chapter 1, the first thing we're going to do is fork that code from the GitHub repo, get it up and running on our local device, and I'll explain what all the files, folders, and functions do so that you have a complete understanding of what it is that we are going to deploy on AWS in chapter 2. Now, once we've got this application up and running, we've seen what local development looks like, including running some super cool tests, because that's super important. Then we are going to deploy it on a few of AWS's most popular services, such as AWS RDS, which is their relational database service. It's essentially everything you could possibly want in an online database management system. So we're going to deploy an RDS. We're also going to have an EC2 instance. Now, this is Amazon's Elastic Cloud Computing Service. What that actually means, who can say, but essentially it's just a virtual machine, which is just another laptop or device or piece of hardware that is running some software, except it's off in the ether. It's inside of one of Amazon's big data centers being super cooled with liquid nitrogen so that it runs efficiently. And we're essentially going to borrow one of these devices and deploy our application on it, connect it to the internet, and it can just sit there running forever. Once we have set up these two services and also completed the 101 steps in between to ensure they are interacting effectively and securely, then we're going to throw in another AWS service, which is the application load balancer. Now, a load balancer, if you're unfamiliar, essentially sits in front of our application and intercepts incoming network traffic and distributes it across our architecture, or the AWS infrastructure that we deploy to run our code. And there are a myriad of benefits to doing this. It's a great service to become familiar with, and I will dive into all of that detail inside of this course. Now, just before we dive into the code, there's a couple of other cool things that you should know about this course. First is that at the very end of this course, I'm going to touch on some of the extension AWS services that you could potentially dive into next. Furthermore, there is a companion guide containing all of the information, explicit instruction detailing all of the steps that we're going to take in this course. That is linked in the description down below. There's a link to the GitHub repo for this course. I'll touch on that more as we get started, but just know that that is there for you. And finally, if you have any questions, qualms, or queries, head over to the Issues tab inside of the GitHub repo and type Help Wanted, whatever it is that your query is, and either myself or someone else will get back to you with an answer to help you overcome whatever challenges you may be encountering. Anywho, with that all said, it's time to go from zero to hero and embark upon our AWS journey. As always, if you enjoyed the course, don't forget to smash the like and subscribe button so that I can continue to feed Doug a healthy diet. All right, it is now time to dive into the code, and we're going to start off this process by downloading the project from GitHub onto our local device and getting it up and running. Now, the GitHub repo containing all of my code can be found linked in the description down below. And to kick this process off, getting it up and running on our local device before we actually go and deploy it on AWS, first, what you'll need to do is come over to this link and you will need to fork the repo and then make sure you have it accessible on your local device. Now, when you come over to the GitHub page, if you could, please star the repo. Love that support. And once you have forked that code and downloaded it to your local device, whether or not you clone it via HTTPS, SSH, or the GitHub CLI, or even GitHub Desktop. I personally use GitHub Desktop. You can also, if you come over to GitHub Desktop on Google, you can download it. It looks a little bit like this. Any of these ways will allow you to get this code base on your device. And if you go ahead and open up that code base once it's on your device inside of a Visual Studio Code window, as I have here, this is the folder directory. We can now go ahead and get our hands dirty. Now to get this up and running, the first thing I want to do is just take a look at what code we actually have. Essentially, we have some config files, importantly as a package.json, which just has some scripts and essentially is the specs file for our NodeJS and Postgres project. So here we have a description of the project, and then if we come down, we have some dependencies. So here we have jest and supertest, and we have some additional dependencies, which are cause.env, express, and Postgres. These are all very important if we want to actually emulate what it would be like to have a production backend application super scalable on AWS, of the likes that you might find in some high-end tech organization. We also have a package-lock.json. We don't need to touch that. We have a .env file. That's going to be pretty important. Actually, you won't have this. So what you will need to do is create a .env file in the top folder directory level and copy across these key value pairs into your environment variable, or these environment variables essentially. Now these are all top secret. And you can see that for the minute, some of them are blank. We will learn how we can fill them out later, but these are very important. And it's also important that the .env file is or specified inside of the .getignore, which you may also have to create, and that's going to prevent all of our secret keys, which are essentially our passwords, from ending up on GitHub publicly exposed to the world. Now, if you're very uncertain about privacy of your application, what you can do is just private your GitHub repo, and then you shouldn't have any issues. I obviously need to have mine public so that you can, download it, fork it, clone it to your device and work with it. So I have to be extra cautious about these keys. Now we also have a readme.md. By the time this video is released, this will be filled out to basically talk about this particular course. And most importantly, we have the instructions.md. Now the instructions.md, right here, it doesn't look so hot flash, but likewise it will also be formatted very soon. So the version of this file that you will be looking at will look absolutely on fleek, super pristine, clear, clean, and concise. But for the minute, it will do the trick to walk us through this tutorial. Now this is a mighty great file with all the steps that we're going to be following to get our backend application up and running using a myriad of AWS services that are all amazing to be familiar with. So this file is essentially going to be our Bible, and this is also a resource that you want to keep on hand, because by no means should you expect to be able to remember this entire process. It's just too niche, too explicit, too specific. So keep this file on hand, and you can always refer back to it in future to see, oh, this is how this particular step works, so on and so forth. So those are some of the important files. As for these folder directories, we have a tests file. This contains a URL shortener .test.javascript, and this uses the Jest framework to write some tests for our little backend application. And then we have a source directory which contains the JavaScript for our Node.js backend application to connect us to the database and all that good stuff. Now the application itself is just a very simple URL shortener where it takes any URL, and when a user wants to shorten that URL, it takes in their URL and it assigns them 3 words, which essentially become the shortened URL for the user. So instead of remembering some random Discord link or whatever it is, you can just remember the 3 words and it will redirect you to the original URL. So it's a pretty nifty little application, and it's the perfect demo for this AWS full course. The hub of our application is the index.javascript. Essentially, we just set up an Express server. We have cause, and then we enable the Express router. We set up some middleware for our Express application, and then we boot it up on localhost 3000. And when it's up and running, we just basically output that our server is running on port 3000. So this file is super straightforward. We have a database.javascript. This file essentially just reads in the environment variables, which are important for accessing our AWS database or our Postgres database. And then essentially what it does is it connects us to the database, and we have a little error handling test for the database connection right here. So if our app is working correctly, we would expect these console logs to be printed. We also have a utils file. This just has a utility function that essentially generates the combination of the 3 words that will be assigned to someone's URL to shorten it. Shorten it, I guess you could also just say it makes it easier to remember. And finally, we have the routes for our application, essentially the API endpoints. One is a / endpoint, and all it does is it returns a 200 status. And this is a health check. Now, there are a lot of ways you can set up a health check. You could put it at the /health path or route for this application. We don't need the /endpoint, so I'm just using it for the health check. And some of our AWS services use a health check to check that our application is actually running. So they ping this endpoint and they expect back a 200 response to see that our server is up and running and healthy. Then we have a route to shorten a URL. Essentially what happens is when someone posts their URL to this particular endpoint, we generate the short path, and then we just write the pair of them to the database. So we have their URL, and we also have the shortened URL. And then the final endpoint, essentially what it does is it just gets that path. So when someone looks up or types in a URL with those 3 keywords, we look in the Postgres database, we search up to find those 3 keywords, and we find the URL that's associated with it, and we redirect them to that URL. So once again, pretty simple application, but it's the perfect demo for this AWS full course. And I actually think it's a pretty cool project. You could literally take this code base and make something absolutely wicked out of it. It works essentially the same as the what 3 words, which is the 3 words that you can use to map to any 1 by 1 meter grid on the face of the earth, which is a kind of cool way to navigate. Now, the one other file that we have down here that I haven't talked about yet is the start_template.sh. Now, this is just a bash executable script, and this is very important because when we set up our virtual private server, which is just our cloud device that is going to run our code for the world to access, we essentially just send over this start script to be executed in that virtual environment, that virtual instance. And what it does is it installs Node, it installs NGINX, it basically pulls down our code repo, and then it boots up our application for us. So it's got all of these commands. It is pretty explicit, and I've made sure to comment through it so you can pretty much walk through and see what all the different commands do in here. So it does make a fair amount of sense. And that's going to be important because when we enable our EC2 instance, which is going to be our virtual private server, then we can just run this script and it's going to initialize our code base and start up our application. So that's going to be super important. Now down the bottom here, what I've done is I've duplicated this file and I've called this secondary one start.sh. Now the reason I've done that is because start.sh is a file inside of gitignore, which means it's not going to end up on our GitHub repo. So it's a very private and secure file. And essentially what we're going to do with it is complete it with some of the important keys and information it needs to run effectively. And then we're going to securely send it over to our virtual private server when we have created and instantiated this virtual private server. So you will want to duplicate the start_template file and just rename it start.sh. So with that all done, let's get our application up and running. And to do that, I'm going to come into instructions. As I said at the beginning of the video, you can watch me do all of this and just become familiar with all the processes and just remember that you have this instruction sheet to come back to at any particular point in time. Or you can literally walk through it with me and do this on your own device. It's totally up to you. Both ways will familiarize yourself with these services to the point that you could put them on your resume or even put them to good use with your own coding infrastructure. So step number 1 is to install PostgreSQL and NodeJS on our device. Now, if you don't, there's 101 million ways you can install both of these on whatever operating system you're on. Linked in the description down below are guides for each, or essentially you can just come over to Google and look up PostgreSQL install or look up NodeJS install and install them on your device. What I'm also going to do at this point is open up a terminal instance right here within VS Code. I'm using the shortcut to open it. You can also do it via the folder options. If you're not familiar with the command or the key code shortcut to toggle a terminal instance like I am just here, you can come over to vscodeshortcuts.smalljames.com, and there's pretty much a list of all the Visual Studio Code hacks that I use to increase my VS Code productivity. So that's something good to be aware of, and that will also be linked in the description down below. Now I'm going to toggle a terminal instance, and the reason I'm going to do that is because I need to type in the node-v command. You can see I'm on version 20.10.0, and I'm going to type in PSQL, which is short for PostgreSQL-v, and that's actually a lie. It's PSQL space -- version. And that's going to come up with my PostgreSQL version, which is 15.1. And the point of both of these commands is just to guarantee that you have in fact installed PostgreSQL and Node.js on your device, which is obviously going to be important if we're going to run this application locally. Now the version shouldn't be too important, and if you have got PostgreSQL running on your device, or essentially downloaded on your device, you will also need to open it up. It might literally be an application that you have to open up. For me, I can toggle it up in the top of my, on the Mac navbar at the top, but you should have Postgres open. If you don't actually have it open on your device as an application, you will not be able to interact with it as a database. Now, one other thing I'd mention about this PSQL command, if you have got Postgres installed and running and this command is not there for you, you can just look up how to install it manually. Pretty much what you do is you just install Postgres via the command line, and then it will come packed or packaged with this command line command, basically. So now that we've confirmed that we have installed PostgreSQL, we've also forked the repo. That's super important, and we've started because we're awesome Small James supporters and I appreciate it deeply. Now what we can do is we can install all of the packages, so that's going to be super important. So inside this terminal we can see that I am inside of the project directory, AWS full course, and I can just type npm I or npm install, hit enter, and that's going to install all of the packages we need to run our application. Now, once I've done that, what I'm going to do is open up a secondary terminal instance by clicking New Terminal right here. And this one is going to be to configure Postgres. Now, what I'm going to do is start off by logging into Postgres using these commands right here. So essentially what I do is I type inside of my terminal PSQL space -u for -user, and the user is Postgres by default. And I'm going to hit enter on that, and that is going to log me into Postgres. Now what I'm going to do in here is start off by creating the database that we're going to be using for the local development of our app. Now we do that with this create database command, and then we name the database that we want to create. So I'm going to type create space database, and you can use all caps if you want. And I'm going to give it a name, which is URL_shortener. And then I'm going to finish the line with a colon, and that is going to command Postgres to create the database. And if we were to actually open up Postgres or the Postgres graphic user interface, we can see just here that I do in fact have this database URL shortener now. So now that I have that database, what we're going to do is basically change directory into it. So we're going to access that database. And we do that with the \c command, and I'm going to / into the URL_shortener, have the colon at the end, and it's going to say you are now connected to database URL shortener as user Postgres. And we can see that the directory basically changed for our Postgres terminal. Now in here, we're going to create a table called URLs, and this is going to contain the URL and its associated 3 words. So I'm just going to copy this command across, and I'm going to paste it in there. Are you sure you want to paste? Yes, I want to paste. And now I'm going to hit enter, and that's going to create that table. And we can confirm that that table is created by using the \dt command. And in here, that's going to list all of our tables within this particular database. And we can see that we do in fact have one row, one instance called URLs. We just created a table called URLs. And this particular table has 3 pieces of information. It has an ID, which is the primary key for our entries in that table. We have a short path, which is of type text, and it has to be unique. Now the short path is the 3 keywords, and then we have the original URL, which is just also type text. So the short path will be associated with an original URL. And so when someone types in the short URL, we basically just look it up, find the original URL, and then redirect them to that. So it's a pretty simple Postgres database, but it's perfect for this demonstration. So now what we're going to do is start up our application, and so I'm going to swap back into the other terminal instance, which is something I can do just over here. So here's my Postgres instance, and here's my regular terminal. And now what I can do is boot up the app typing npm run dev, which is going to run the development script, which is just here. So here's our script. So it's going to use Node, access the source directory, and start up the index.javascript file, which is going to boot up our Express server, and it's going to listen to these incoming network requests. And now we can see that our server is running on port 3000, and we have successfully connected to Postgres, which is perfect. So that means that our Postgres database is running and our server is listening to incoming net requests on port 3000. Now that that's running, we could actually go ahead and test it. So I could open up another terminal instance, and in here I could just write curl -i flag to get back all the header parameters of our request or the response. And I could just say http://localhost 3000, and I would expect to get back a 200 network request from that. And we can see that if I hit enter on that, we can see we do in fact get back a 200, which is okay. And this is the header information associated with that response. And that just confirms that our server is in fact up and running, and we would have hit this first endpoint. Now what you could do in here is test the URL. So I've created the curl commands to test the URL. So we can test this first one, which creates a shortened URL for https example.com. So what we can do is copy that command, and I can paste it into the terminal, hit enter, and we can see we get back a short URL, which is the /go to yak whale dog. So that's the shortened URL, the 3 keyword URL. And then what we can do is just copy those 3 keywords, and paste it at the end of this second command, which would be the shortened URL that we'd basically paste into Google or our web browser. So I would paste in this URL, and I would expect to be redirected to example.com. So I should actually be able to do this in my browser, paste in this command, and it should redirect me to example.com, which is exactly what happens. So I will have sent out that network request. I wonder if there's a history of it. Can we come into network and look at the history? Let's try that again. If I hit enter, we can see we send out this network request to localhost. We get a found, and then we get redirected, which is the 302, and the redirect takes us to example.com. So that's working perfectly. If I were to try a different one, let's go yak whale dog, and instead of dog put cat, we just get an error that says URL not found. So that's working perfectly. That's all good. So now that our application is running, what we can do is quit out of everything. We've basically set up the database. We can type in the quit command to exit Postgres, and we can Control-C to exit out of our server. And the reason we're going to do that is because we are now ready to run some tests. And once we have confirmed that our tests are working, then we can go and set everything up because we know our code is on point. Now, the way that we test our application is pretty straightforward. Inside of package.json, we can see we have a test script, and that just runs jest, which sets up or basically runs this test file. Now, in a production environment where you've got lots of changes and you're going to push a new change to your production environment, essentially what you would do is you would just run your tests on your local device to confirm that your changes have worked, and then we'll see later how you would modify the production basically version of your application. Now, one thing I'd mention is that for this course, I'm not going to set up a CI/CD pipeline because it's a little bit outside the realm of directly learning AWS features and functionalities, the different services. However, if you want to subscribe, that will be a course coming in future dedicated entirely to CI/CD with AWS Code Deploy and GitHub Actions. But we don't need it in this case, and you will see why shortly. But what I'm going to do is run that npm test command, hit enter, and that's going to run all of our tests, and we can see that we passed all of them. So everything is working perfectly. We passed 4 out of 4 tests. And so now we are ready to basically deploy our application to whatever AWS monstrosity it is that we're about to create. So this part of the course is pretty much going to be entirely in our browser, and we're going to start off by just typing in AWS on Google and clicking on Amazon Web Services. Now, once on this website, which is also going to be linked in the description down below, we're going to click to sign into the console. That's where all of the magic is going to happen. And here we're going to be asked to log into the Amazon Web Services console. I'm going to sign in using a root user. And then once I've completed the sign-in process, that's going to bring me to the console home. Now, as I said earlier, unless you've found a free trial of AWS or you have a whole lot of free credits, you will need to enable billing for this project. At the end of the course, I'm going to show you how to shut everything down so that you do not incur any costs. This is going to be an extremely cheap service to basically set up and running. So even if you do enable it, it's not going to cost you an arm and a leg. I can guarantee you that. However, at the end of the day, to use these cloud resources, they do cost money, and consequently Amazon or AWS will expect to be able to bill you for the services that you are using. So if you're looking to enable billing, essentially what you can do is come over to billing and cost management. Now, if you want to skip this part, that's absolutely fine, because most of the services that we're going to use are going to be the free tier equivalents. Obviously, you could boost them up if you had a production-sized application or if you exceeded the free tier. But to enable your billing, essentially, I can just click on billing and cost management, but you could just search up here. If you type in billing into the search bar, billing and cost management is the second thing that comes up there, and you just need to basically add a card for them to charge you on. You could also put in budgets and limits so that they can never charge you too much. Once again, totally up to you. You should be able to get away using free tiers for everything if you've just signed up for AWS, and even if you've had an existing account for a while, I think most of the stuff in here is free tier. There are a couple of services that may incur a charge, but once again, we'll shut everything down at the end, and you will have an amazing experience for a very, you're going to get a minuscule bill. Anywho, once that has been sorted, we are going to start off using our first AWS service. Is going to be AWS RDS. Now, AWS RDS, up in the search bar, I can type in RDS, and that's going to bring up Aurora and RDS, a managed relational database service. And I'm going to go ahead and click on that. Now, essentially what this is it's basically an AWS database, and we're going to create one, and you can create any kind of database that you like. So once on this particular page, what we're going to do is scroll down inside of RDS. We can see we're inside of Amazon RDS over here. We're going to scroll down and select Create Database. Now inside here, there's two options. There's an easy create or there's a standard create. We're going to go with the standard create because this course is to learn AWS, not skip all the important steps. And in our case, we're going to be using Postgres. Now, AWS has a version of Postgres called Aurora, and it basically is Postgres with extra steps. We don't need that in this case. We're just going to keep our setup nice and simple. And one thing I would comment at this point is that there's actually a bunch of ways you could set up your own Postgres database. For example, the way that we deploy our application, you could set up a Postgres database exactly the same way. But because that would be doing the same thing twice, I figured it would be better to demonstrate how we can use the AWS RDS service instead of doing it the alternate way. And doing it this way kind of gives you some extra benefits, so I think it's worth doing. So we're going to select PostgreSQL for our engine option. Now if we scroll down, it's going to have some filters. We don't need any. An engine version, we're just going to stick with the recommended one. We're not going to enable RDS extended support. And then we're going to come down to the templates. Now in here, we are going to click on the free tier. You could go for production, you could go for dev and test. We're just going to go for the free tier to gain hands-on experience with Amazon RDS. But you would, potentially use a production environment if that's what you are actually doing. For the free tier, that's going to limit us to this particular instance for availability and durability. If you were in production, you would potentially select from one of the two. The different benefits are stated within, but we're just going to go with the free tier option. And then if we scroll down here, we can get to our settings. Now the first setting is the database name. In this case, I'm going to name it URL-shortener per the guide. Pretty straightforward. And then underneath that, we're going to give it a master username. Now the master username is going to be URL_shortener, and all of this is going to be lowercase. Now as for the password, we're going to auto-generate a self-managed password. You could use AWS Secrets Manager, but we're not going to worry about it. That would be a pretty easy AWS service to get up and running with. But we're just going to self-manage a password, and in this case, I'm going to auto-generate it. Now this is going to say you can view your credentials after you create the database. Click the view credentials detail. Don't let me forget to do that. Literally comment down below, James, don't forget to view the password, otherwise it's super annoying, in the comments down below so that I don't forget. And if you don't, then I probably will have forgotten, and we will have to figure out what we do in that case. If you do forget to view your password when you create the database, in the guide, there's instructions on how you can go ahead and find the password regardless, but you would have to pretty much reset it. So if possible, the one time they show it to you, take a record of it. But we'll do that together. If you comment down below, James, don't forget your password. So now we're going to come down to the instance configuration, and we're just going to pretty much stick with the one that they recommend, which is this one right here. So it's 2 virtual CPUs, 1 GB of RAM, and up to 2085 megabits or megabytes per second. I'm not sure which one it is, but that should be more than sufficient for us. And then if we come down, we have allocated storage, and the minimum allocated storage is pretty much 20 GB. So that's just what we're going to use in this case. And if you're not sure what a GIB is, it's relatively equivalent to a gigabyte. Pretty equivalent. So now we come down to connectivity, and essentially this is what we want to wire up our RDS instance to. Now in here, currently it's selected don't connect to an EC2 compute resource. Now Amazon or AWS EC2 is actually the second service we're going to get up and running with, and it is a super very important service. It's actually going to be critical for us to deploy our application. Now, if you're unfamiliar with Amazon EC2, essentially all it is Amazon Elastic Compute Cloud. Now, that's a whole lot of fancy words, but essentially what it is just a virtual environment. So here the question on Google, is EC2 just a virtual machine? Yeah, pretty much. Amazon EC2 is a service you use to create and run virtual machines in the cloud. So essentially, if you're not sure what a virtual machine is, it's pretty much just your computer, but it's not actually your computer. It's owned by AWS and it's in the cloud, which just means that it's on their hard drives or their servers basically. And they allocate you that resource and you can interact with it via the cloud, configure it, make it live, accessible to the internet so that everyone can access your server. So it's pretty much just a computer far, far away that we're going to manage from our computer and set it up so that it's permanently running our application. Now currently we haven't connected to an EC2 instance, so what I'm going to do is connect to an EC2 compute resource, which is just our virtual machine, and in here it's going to ask us to select an EC2 instance. Now because we don't currently have one, what we're going to do is pause our AWS RDS setup, and we're going to click to create an EC2 instance. Now if this doesn't show up for you, you can just come up to the search bar and go EC2 and open that up in a new tab. That would be absolutely fine. I'm going to click this link right here and it's going to open up a new tab for Amazon EC2, AWS EC2. Now what we're going to do in here is launch an instance. We're going to launch a singular instance. Obviously, if you had a massive application, you might want to boost that number so that you could potentially split the load amongst all of them. For this particular service, there is a free tier, so in your first year of opening an AWS account, you get 750 hours per month of this particular instance, which is a load more than you will absolutely need. And essentially what we're going to do is just start off one for this demonstration, and we're going to give it a name, and this is just going to be URL-shortener-EC2. And then down here what we're going to do is select the application and operating system images. We're going to stick with Amazon Linux. So this is just the operating system that's going to be installed on our virtual machine. Amazon Linux is more than sufficient. It's pretty good. It's also pre-installed with the Amazon or AWS CLI, which is super convenient for future, and it has long-term support from AWS, and I think it also boots up faster according to my research. Now underneath that we're going to come down, we're going to just stick with the original Linux image. That's all we need. Once again, that's just about the operating system, and then come down, we're not going to change any of the architecture or any of that kind of stuff. Now here we see that the username is EC2 user. This is super important and we will revisit this shortly. We'll see it crop up a whole lot. And yeah, just to summarize, we only need one instance. If you had a massive application, you might have numerous instances. For example, it could also be useful in the case where you're deploying your code, one instance goes offline, another is there to back up, and you can manage different instances in a bunch of different ways. For example, with a load balancer, which we will actually be adding in this course. If you don't know what a load balancer is, we'll touch on it when we get to it. So now we're going to come down to instance type. We just pretty much want the free tier eligible one. There's a bunch of different instances you could have here depending on the service you're trying to run. They have their associated costs down beneath them. Some are definitely more expensive than others, but we're just pretty happy with the free tier one. And then we're going to come down to key pair, which is the login. Now in here, I already have a key pair, but we're going to create a key pair. And this is super important because you can use a key pair to securely connect to your instance. Now we are going to have to connect to our instance a whole lot because it's the only way we can pretty much tunnel into that virtual machine and then run a whole lot of commands to boot up our application like hacker programmers. So what we're going to do is create a new pair. I'm going to name this new pair URL-shortener-EC2. We're happy with the RS2 encryption type. That's absolutely fine. The key format should be .pem. For use with OpenSSH, we're going to be using SSH to log in, so that's exactly what we want. And then we're going to click Create Key Pair. Now when you click Create Key Pair, it's going to ask to download that key onto your device, and this is super important. Now when it comes to picking a location or folder to store this key, we are going to come over to our code repo, which is the AWS full course, and just save it in there. So I'm going to save this key inside of my AWS full course folder. Now one very important thing that we're going to have to do, here I have my key, we can see it's been saved in the side we absolutely critically have to add the name of this key to the .get ignored. This will already be done if you're copying my code. So essentially what we're going to do is paste in that name .pem, save that, so that this key is ignored. You do not want this key visible to anybody. That is super important, insanely important, because if they get access to this key, they can just hack into your instance and do whatever they want, which would be super problematic. So this key is a one and done. It's only for us, and we're going to use it so that we can log into our EC2 instance and boot up our application, or redeploy it if we've pushed changes to our code base. So now that we have that key pair, it is specified just here. What we can do is keep scrolling down and come to the network settings. Now for network settings, what we want to do is create a security group. We're not really going to worry about any of this stuff up top. And just underneath where it says create the security group, and here we allow SSH traffic from SSH, and we want to allow SSH traffic from our IP address. Now, one thing this is going to do is it's going to only allow you to SSH into this instance when you are on the IP address that you are using to create this EC2 instance. Now, hypothetically, if in future you change your IP address, which means basically you connect to the internet via a different means, could be going from wireless to Ethernet port, or it could be, literally on a different Wi-Fi network, or, via mobile, what you would need to do is add another secure IP address. And once again, if you want to do that, that guide is inside of the instructions.sh how you can do that. So I'm just going to allow SSH traffic from my IP address, and I'm also going to allow HTTP traffic from the internet. Now this is super important because obviously we will need to, allow network requests to access our EC2 instance so that they can get to our application. Now this is only temporary. Eventually when we create our load balancer, we're going to remove this setting. And when we do the load balancer, you'll also see how you could potentially add an SSL certificate or a domain name to your application to then allow HTTPS traffic. But for now, we just want to allow HTTP traffic from the internet because we need to be able to send a network request over to our server, which is deployed inside of the EC2 instance, and have it respond back to us. So now we're going to come down to storage. I'm not going to modify these settings. They're absolutely sufficient for us for the minute. If you're wondering what these things mean, the GP3 is just a general purpose SSD. The 3000 IOPS just means input output per second, operations per second, and we don't need it encrypted. In terms of adding a new volume, you would do this if your app stores large files, which I don't think is going to be an issue for us. And you can come back and add extra storage at any point, so it's not really that important. And you can even add the storage without having to turn off your EC2 instance while that's being allocated. So that's pretty all good for the minute. We don't have to worry about advanced settings. Now what we can do is all I've done just here is come down to the summary. So this is our little summary right here. We have one instance. This is all of the information. And we can go ahead and launch the instance. So I'm going to go ahead and click Launch Instance. So that's going to go and provision us our EC2 instance. So I can come over to Instances within EC2, and it is available right there. We can see that it's running. And now I can come back into Amazon RDS, click this little refresh, and now I can click on my URL shortener EC2 instance. So now that we have selected an instance, it's going to remove our ability to select a virtual private cloud. That's totally not important and more than acceptable. And then we're just going to scroll down and look at some of the other config for our database. Now for the database subnet group, we're going to have an automatic setup. That is absolutely fine. For the public access, no, we do not want public access. And public access went away when we allocated our EC2 instance. So now we can only interact with our database via the EC2 instance, which is pretty much how we would want it. As for the VPC security group, we want to choose the existing, and where it says additional VPC security group, and this just says Amazon RDS will add a new VPC security group to allow connectivity with your compute resource. So actually what we can do is actually exit that. You don't need to even select one. Amazon RDS is going to add a new VPC security group. That's what we want. This is the option we want to continue with. Underneath that, we can come down to the certificate. We're just going to leave that as default. Using a server certificate provides an extra layer of security by validating a connection. We don't have to worry about that. For the tags, you could add them if you want. I'm not going to bother. We want password authentication into our Postgres database. That is super important. That's how we're going to stick with it. You could use the IAM database authentication, but in our particular course, this is just going to add, extra steps that we don't have to worry about. We'll come down to monitoring. We're just going to stick with the default options. Go with the free tier retention period, which is for all of the logs and data. And underneath that, we have the AWS master key. And we're just going to stick with the default option for that. And now we can pretty much come down the very bottom. I'm not going to worry about enabling monitoring or where the logs get posted to. That's absolutely fine. So pretty much now what we can do is scroll down the very bottom. And here we're told that Amazon RDS free tier is available to you for 12 months. So, lucky you guys, the EC2 and the RDS are available for free for a long time. That's how they hook you. It's a bit like a drug, and then you'll never leave. And then next year you'll be paying for it. But you won't be paying much because this is a pretty cost-effective way to deploy your applications. So now what we're going to do is click Create Database with all of that configured. Once again, all of this is detailed in the instructions markdown file, which can be found on GitHub, or if you fork the code repo, it's right there for you. So I'm going to click Create the Database, and that is going to provision us our RDS database. So just here we can see it. We see that it is being created. It's a Postgres instance. We can see the region, and then we have some other important information like the VPC and all this kind of stuff. We can click on the database, come into it, and there's some important information in here that we will be fiddling with in just a second. For example, the endpoint. We're going to need an endpoint so that we can access it via our EC2 instance. Now this might take a few minutes to launch. The only way to view your master password is to choose View Credentials Details during database creation. So what I'm going to do is click View Credentials Details right here during database creation. This is super important. Now just here it's going to give me my database name and the master password. I'm going to copy this because this is the only time you can view the password. I'm going to copy that master password, and I'm going to come over to my .env file, and just next to the database password, I'm going to paste it in. So just here you can see I've pasted it in. It's quite a few characters long. I'm not going to show you all of it. And once I've pasted it in, I'm going to save that and close the .env file. And so now that we have provisioned our EC2 instance, our cloud computer running on some of Amazon's, massive servers, in addition to our RDS database, the fun part truly begins where we can SSH tunnel into our virtual machine and set it up to run our application. Now there's quite a few steps that we will need to follow just here, and a lot of it is going to happen within our code editor. So the first thing we need to do is to find some information about our database. So we're going to come back over to RDS and look for our URL shortener database. So it's just reloading here. And I can see right here that I'm inside of my URL shortener database. And once I'm in here, I'm going to scroll down and click on this configuration tab. Now the config tab is going to have a master username. So this is our master username. And this is super important because we're going to paste this into our .env file. So just here we can see that we have the database name, and that's going to be set equal to URL shortener to match this URL shortener username. Now we are also going to need to take the endpoint. So what I'm going to do within RDS is click on the connectivity and security, and I'm going to copy this RDS endpoint right here. I can click the copy, and what I'm going to do is inside of the .env file, I'm going to paste that adjacent to this database underscore or db underscore host. Just like that. Then I'm going to save this file. And now that that is in there, I can close my .env, and then our EC2 instance, when we copy across the .env file, will be able to connect to RDS. So that is super important. Now, if you did forget to take your password and you need to reset it, the instructions are just here. We've already got our endpoint, so that's absolutely fine. And now what we're going to do is SSH into our EC2 instance. So first, what we're going to need for that process is to come back over to it and find our public IP address. So just here, what I can do is click on this instance, and that's going to give us access to this public IP address. So here's an example of what one would look like. And now that we have access to that, just here we have the command to SSH into that file. Now, to explain a little bit about what some of the parameters in this SSH command mean, essentially the -i flag allows us to use the .pem or the key to authenticate ourselves. And then the second entity right here is pretty much just the username and the IP address that we're trying to access. So what we're going to do down here in our terminal, I'm going to close the side for the second, is I'm going to type SSH -i space -i, and then I'm going to look for my file. Well, it's actually in this folder directory, so it's just down here, so I can pass it in directly. We're going to type URL dash, or actually /URL dash shortener dash EC2 .pem, and then after that, what we're going to type is EC2 dash user. If you remember, that's our username, and then we're going to have the @ command, and now we're going to paste in that IP address. So now what I should be able to do is hit enter, and this is going to log us into our EC2 instance. Now that was denied, and that's because I forgot to do one important thing, and that's run this particular command just here. Now the reason it's denied is actually given to us right here. It says that the permissions for this particular security key are too open. We can fix that by tightening the permissions using this command right here. So we just type chmod, permission is 400, that's an important keyword, and then we just type // and then we type the actual file name, which is URL dash shortener dash EC2 dash or .pem. So if I hit enter on that, that's going to tighten the permissions, and then I can go ahead and rerun this original command, hit enter, and that has now logged us into our AWS EC2 instance. So how cool is that? This, I presume, is meant to be a map of the region. I actually don't know. If you do know what this little picture is here, let me know in the comments down below. But we can see just here that we are in fact inside our instance, so that's super cool. So now that we're in here, what we need to do is run some commands. So the first thing to know is that Amazon Linux 2023, which is the operating system that we've installed, does not include Postgres by default. So what we have to do is install Postgres 15. So what we do is we type sudo DNF is the package library that we're going to be using, and we just type install, we use the -y flag, and then we just type PostgreSQL and version 15. So here you can see it, both Yum and DNF are package managers used in Red Hat based Linux distributions. So that's super important. And so now what I'm going to do is hit enter on that, and that is going to install Postgres on our EC2 instance, and that is now complete. So that command is right here, sudo dnf install -y PostgreSQL 15. So now what we can do, since we have Postgres, is we can test this Postgres command as we did earlier on our local device. We can type psql-version, and that comes up with a version of Postgres that we've installed. Obviously you could select a different version, that's up to you, but 15 will work for the minute. So now that we have that, we should be able to log into our database from the command line, which is super cool. And so we can just type PSQL, and we can type -h, and then we can pass in the PostgreSQL endpoint. That's super important. And remember, we set up the security so that we can only access our RDS instance via the EC2. So we're already inside our EC2 instance somewhere off in the world, that computer. So we should now be able to access this endpoint from our PostgreSQL command. And then what we need to do is type -u Postgres, and then -d Postgres, and then we need a password. So this is an example of what a password would look like. So we can go ahead and hit enter on this command. I realize you can't actually see it, so let me fix that for you. So here is the URL, and then we have -U, the user is Postgres, -d for Postgres, that's the database. So let's hit enter. The command is not found. And that's because I didn't type it in correctly. I did PQSL, it's PSQL. So let's just jump back and do that again. So that should be PSQL. Hit enter on that. That's going to ask for a password. We're going to use the password that we specified inside of the .env file. So I just went into my .env file and copied that password, and now I'm going to paste it in here. It won't show up any keys because it doesn't show you how long the password is. So I know I have posted it or pasted it, and now I can hit enter. And that says error, password authentication failed. And I'm a complete muppet. I totally realize why this is not working. What is the username? The username is not Postgres. It's URL _ shortener. Then we paste in the password, and then it logs us in. Honestly, I spent a good half an hour trying to figure out why that wasn't working, and it's just because I'm a muppet and I was using the wrong username. But then again, this stuff happens, so it's a good learning experience. So now that we have in fact logged into our database, we can come right up to the very top and just configure it. So we're now logged in, so we can copy in these commands directly into Postgres. That's going to create the database. This one is going to change the directory into the URL shortener. We can see we changed directory. And then we can create the tables. So I can literally paste in that command, hit enter, and that has now created the tables. And I can use the \DT command to show me that I have in fact created said tables. And so now that we have created the database, eventually what we'll be able to do is run these commands and get that all working. Basically, use our application from our local host. So now that we have the database working, what we need to do is pretty much get our application over there. So essentially what we're going to do is we're going to send across two files. One is going to be this start.sh, and one is going to be this URL shortener. Now if I come into the template just here, we'll see that we have a whole lot of variables right here. Now these variables are super important because we're going to pull down the repo from GitHub, and so you're going to need access to your GitHub username. We're going to specify the repo, and we're also going to need a GitHub token. That's very important. Now if we scroll down, pretty much these are all the instructions that our script is going to follow to get our application up and running. For example, it's going to install NodeJS. That's super important. It's going to install NGINX. It's then going to clone the repo onto our local or onto that cloud machine, that virtual machine. And then it's going to install the Node.js dependencies. It's going to create a .env file if it doesn't already exist, but it will exist because we're going to send it over there. And then we're going to set up a reverse proxy, which is kind of just like a bouncer for our application. He's the security guard for incoming network requests, and if he deems them cool, or she or they or whoever, then they will forward them to our actual application. So this NGINX server is going to listen for HTTP traffic on port 80 and then redirect it. It's going to be a proxy for our actual application, which is going to be on our localhost 3000. So it forwards requests to our Node.js application. Then we're going to boot up NGINX so that that server is running. And then we're going to start our application with PM2. So that's just going to get it up and running so that we can then use it. Now I've also added a whole lot of information down here for if you have an SSL certificate, so you basically have an HTTPS secure domain or certified domain. There's a couple ways you can go about adding it. This is one way. We'll also look at how you could do it with the load balancer that we will add later. So to get pretty much the ones that we need to specify is the GitHub username, the repo, and the token. So what I'm going to do is come into start.sh. Keep in mind this is my version. Here we have my GitHub username. I also have the name of the GitHub repo, and then just beneath here I have my GitHub key, which I think has expired, so I will need another one. So what we're going to do is come over to GitHub. I think these keys are going to be under our settings. So what we're going to do is come over to our page just here, or our little logo icon, and then I'm going to click on settings, which is just behind my head. You can just see it underneath feature preview. Once settings is open, then we're going to scroll down and we're going to come into developer settings, and then we're going to come over to personal access tokens, and just here you can see that I've already created a key that's recently expired. What we're going to do is generate a new token just like that. And now we can give the token a name. I'm going to say AWS URL shortener. And you can put an expiry on it if you want. I'm going to go for 7 days. You could go for a very long time, no expiration, depending on what your intention with this is. We can put a description in here. Just say this key is for my EC2 instance to pull down my code and then run it. Repo access, we're just going to give it only selected repo access. We're going to go for the AWS full course repo. And then you just want permissions. So pretty much what we want is for the key to be able to read the content. Sorry, that was the wrong one. No access. We want to read the content. The contents, repo contents. We don't want any of the commit statuses. We don't need any of the code space metadata. We don't need the actions, admin, code scanning, code spaces, create. Nope. We don't need deployments. We don't need discussions. We don't need environments or issues, merge queues, metadata, pages. No. Pull requests, no. Secrets, variables, webhooks, workflows. I think that should just be it. That's the only one we need is the contents, and we can set it to read only. So now we can scroll down. We can see what two permissions are there, contents and metadata. I think that's fine. And now we can go ahead and generate that token. Now when you clicked generate, you'll get a page. You can just see the side of mine here that has your actual token. Copy it. And I want you to paste it just in here adjacent to the GitHub token, and then click save. So now that we've saved our personal version of start.sh, I don't think we need to modify any of the other values. What we can do is send it right over to our EC2 instance. Now the way that we do that is via scp, which is a command that's similar to SSH to copy elements into our container. So what we do is we call the scp and we give it the .pem file, our token. We select the file that we want to send, and then we send it to the directory. So what I'm going to do is I'm going to stay inside of my EC2 instance here, but I'm going to come over to a different terminal instance. And then what I'm going to do is just copy this pretty much directly in. So I'm going to type scp-i. The token is ./url-shortener-ec2.pem. And then what I want after that is to specify the file that we're sending. So it's start.sh. And then we need ec2-user@. And in here we're going to put in our public IP address. So I'm going to come over to our instance, copy that public IP address, paste that in. And then after that we're going to have the colon, then a /home, and then a /ec2-user. So that's the actual folder directory. So it's a little bit of a command. You can see it pretty much just here. All you want to change in this section is the EC2 public IP. So I'm going to hit enter on that, and that should send that file over, and it is now complete. And the other one I want to send over is the .env file. So I'm going to repeat that, except now I'm going to change the change it to the .env, and I'm going to send that over as well. So now I have two files on my EC2 container. I have the start script, and I have the .env file. And so now that that has been sent over, or both those files have been sent over, what we can do is come back to our terminal instance where we have logged into our EC2 instance. And the first thing we have to do is run a very simple command here. So currently we use curl to execute these commands. It's to basically do a whole lot of stuff. We need to swap out the curl package with a secondary package, or basically a different version of itself. So currently curl minimal is installed. Curl minimal is just used for creating network requests pretty much. And so what we're going to have to do is run this command here. It's going to swap minimal curl for full curl. So I'm going to paste that in to our instance and run that command, and that's going to basically install full curl, which, as I said earlier, allows us to run network requests from the command line. And then I'm going to create a directory called /var/www. Going to paste that in. That's going to create that directory. Now we need to grant some permissions to this directory. Amazon Linux restricts write access to this directory, which is usually reserved for web servers. Well, lo and behold, we are creating one, and this is to allow cloning the repo into this directory. So we're going to run this command right here. It's basically going to give permission to our EC2 user to do whatever it wants. Paste that in. That's going to adjust the permissions and changes the ownership of this folder to your current user, and allows Git to clone to write files to this directory. So now the last thing we're going to have to do is just set some permissions to this folder. It's a whole lot of faff, I appreciate that, but all very important steps. So now that all of this is done, we can basically pretty much run our file. Now, just before we run an executable, we have to give it permission to run the executable. So that's the chmod +x, and we specify the start.sh file. So hit enter on that. That's going to allow us to now execute the file by typing /start.sh. That's going to run everything. All of these codes just here, or all of this stuff, is installing Node, it's installing NGINX, it's basically pulling down our repo. We should see that come down in a second. And it's just going through all the commands inside of our start.sh file. We could see that Node was installed. We can see that now it's configuring NGINX as a reverse proxy. And we can see that now it is starting our application with PM2. And up here we can see that the repo was cloned as well. And just like that, our application is up and running. How cool is that? Now, to confirm that our application is up and running, what we can do is type a couple of things. First, we can type PM2 list. And here we can see we have one app, it's online, and that's what it's doing. What we can also do to test that NGINX is working is we can type sudo nginx-t. And this pretty much just says the test is successful and the syntax is okay. Now, if you were getting any issues, what you could do is copy this command and get 100 lines of logs from PM2. And we can see that we actually do have an issue. So the database connection was errored, which means that our RDS endpoint was not happy. And so the issue is actually happening because we're looking for the endpoint called your RDS endpoint, and we can see that that comes from our template just here. That's how we wrote it in. Now, technically, you could use this script to write your endpoint, and you could keep your environment variables in here. But what we're going to do, since we've already copied across the env file, and if you don't remember how to do that, we can very simply do it again. We pretty much just run this command right here, where we send over the .env file. I can send that across. That is now sent to my EC2 instance. We use the SCP, which is the secure copy protocol. And now inside of our EC2 user, if I type ls, we can see, well, it won't show it to you because it's a .env file, but it is right there. I can type cat.env, and this command will show me all the contents, but I'm not going to do that because that would expose all of my secret information. So what we need to do now is actually move this env file into our project directory. That's what's actually going wrong. So we've just copied our env file into some random directory. I have a command here to figure out the directory. Well, the point is currently we're at this directory. We're at /home/ec2 user. We need to be at /var/ww/my_app. Now this directory will exist because not only did we create this directory earlier and we enabled, writing permission, but then when we ran our start.sh script, it cloned the repo into a folder called my app. So we need to send our environment variable off this directory into this directory, and we do that with a very simple command. I've got it written here. It's also in the instructions. Here it is. Sudo move. So sudo says, I am the ultimate God, do as I say. Move means move. We want to move from, or this is basically the file directory where it currently is, home/ec2 user/.env. And we want to move it to the destination folder, which is /var/ww/my_app. So I can hit enter on that, and that is going to move that file into that folder directory. And what I can do now is I can once again run my /start.sh. And what this is going to do, it's not going to, because technically it's going to pull any changes that were pushed to our code base. That's not so important, but one thing that could, or you could think would happen, if we pull down the folder again, won't it overwrite the file, the env file that we've just copied across? And no, it won't. If the directory is already there, then all we do is we pull any changes. So there's not any changes. Our env file, our new env file that we've pasted in will still be there. So I can go ahead and run that start.sh script. That's going to do everything all over again, skip the steps. It doesn't need to repeat, and boot up our application. So now we can see that our app is up and running, and what I can do is run the pm2 logs -- lines command, and we'll see now, instead of getting that nasty error, we see that our server is running on port 3000, and we also see that we have successfully connected to our RDS Postgres instance. So that is super cool, and the coolest thing about it is that what I can now do is test the URL. So I can once again copy this curl command, copy the whole thing, including the final singular quotation, but not the backtick character. And I can very simply paste that in. And we can see that it has returned to me the short URL. And the three keywords are xylophone, banana, and banana. And so what I can do is I can just paste those right there. And so now if I were to run this curl command, this is to basically, as if I were typing in the website in Google, it should redirect me to the link that I have saved, where the original URL is example.com. This is the shortened URL. So this is equivalent to me pasting in the shortened URL to Google. Now I run that. Something went wrong. It's because there's a backtick on the end. Let me just remove that. I run that. And now we see that we find it, we get redirected, we get a 302 response from our server, and we get redirected to example.com. So that is working perfectly. We can see that our database is literally working. So now that's the case for the local interactivity. What if I wasn't SSH'd into my EC2 container where I can access the service locally? What if I wanted to send a request to the EC2 instance? It would be met with our NGINX proxy, which is a proxy for our server, where if you're unfamiliar with what a proxy is, it's basically an equivalent. We call it an equivalent because it stands in front and it basically doesn't let the user see what's going on behind the scenes. So it's more or less the same thing, except in reality, our NGINX server just redirects to our local host NodeJS application. But the point is, I would send this network request from any device globally, so outside of my EC2 container. So what we need to do is find the port for our EC2 container, which I realize I've already found a bunch of times, but it's just here. It's on the EC2 instances page, and I've clicked on my instance. And so what I can do is just paste it in place of this top one right here, this top curl command. And now what I should be able to do is copy this command, which is just going to emulate this network request, come into a terminal instance where I'm not actually logged in to my EC2 instance. So just here, paste that in, go to shorten it, hit enter. Lo and behold, the magic is complete. So we got back a short URL, which means that I should be able to slam this on the end. We can see that the keywords are apple, vulture, and monkey, and I should now be able to go paste that in and copy this URL. We don't want the 3000 in there, but I don't think that'll be there for you. Copy this URL, paste it into my browser, hit enter. And I realized the reason that's not working, that's because we very much don't have the correct IP address on this. I'm a silly muppet. So let's make sure we paste in the correct IP, and now I should be able to copy that, close this one, paste it in here, and it redirects me to example.com. So that is we literally pretending to be a user, and we have just connected to our EC2 instance. We've hit our Node.js application, we've communicated with our RDS instance, and we've been redirected to our domain. So our application, for all intents and purposes, is live on the internet. 10 out of 10 props to you. You're an absolute legend. Now, just because it's live on the internet doesn't mean that we're done yet. There's a couple of extra steps that we need to take, such as the application load balancer. But for all intents and purposes, our server is now live on the internet. Now, you could stop here because technically it's live. That kind of works. You could add the SSL certificate via NGINX. And all you would do every time you push changes to your GitHub after you've ideally run your tests is you would just rerun the start script. You'd SSH into it, rerun the start script, and that new code would be downloaded and deployed on your EC2 instance. So that's absolutely one way you can do it. So you could park the video here if you're totally content with that, but there's a couple of extra steps that you totally can take that I would recommend taking that we are going to dive into now. So first up, what I'm going to do is dive into the application load balancer. So I'm going to open up a new tab. I'm going to keep a tab open for each of the things. Kind of feels like the appropriate way to do it. And I'm going to look up load balancers. Well, actually, no, I lie. We can be within our EC2 instance. So let's come back to our EC2 instance right here. We can scroll down and we can see load balancers available on the side. So I'm going to click on load balancers. Now, once here, what I'm going to do is click on create a load balancer. And once again, all of these instructions are available inside of the instructions.md. Now, before we create the application load balancer, let's actually understand why we want to do it. So the first thing it does is it basically is a layer in front of all the traffic that reaches our application. So it handles the incoming traffic and it distributes it across multiple EC2 instances. Now, currently we only have one. Even if you only have one EC2 instance, there are still numerous benefits from having an application load balancer sitting in front of your application. For example, it provides automatic failover if an instance crashes. It supports HTTPS with an SSL certificate. It improves security, and there's a couple of other reasons. I can't remember if I've included them in here. There's quite a few steps to this particular process, but end of the day, it's just a great thing to have, especially if you're going to scale your application eventually. So we've already gone to the AWS console, to the load balancer. We're going to click create a load balancer, and we want to select the application load balancer. So that's the one on the left hand side here, and that's because we want an application load balancer for HTTP and HTTPS traffic. That's exactly what we have. So here it shows you a little bit about how application load balancers work. Clients make the request to your application. The listeners in your load balancer receive the request matching the protocol and the port. The receiving listener evaluates the incoming request against the rules you specify, and if applicable, routes the request to an appropriate target group, where a target group is pretty much just our application. The other cool thing it has is health checks. So essentially it will regularly ping your application to make sure it's working. And if you recall, if we come into routes, that's why we have this health route right here. So when we receive this request to this particular endpoint from our load balancer, it just sends back a 200 saying our application is still good, we're ready for these incoming requests. And we can see it can do it either via HTTPS or HTTP, so port 80 or port 443. So what we're going to do now is scroll down a little bit and configure some settings. So I'm just going to copy the name. We're going to call it URL shortener -ALB using dashes instead of spaces. And we want it to be we want it to be internet facing because users access it from the internet. That seems kind of intuitive. We're happy with IP addresses for that system. That's absolutely fine. We can scroll down to the network mapping. And the main thing here is that you just have to select 2 availability zones. So select at least 2 of it. We don't need to worry about this option right here. We're just going to leave it. But we need to select 2 availability zones and a subnet for each zone. A load balancer will be placed in each selected zone and will automatically scale in response to the traffic. So I'm literally just going to pick the top 2, and we're just going to leave the default subnets. Now, if we scroll down to security groups, this part is actually pretty important. So what I'm going to do is start off by removing the default security group. Now, our application load balancer needs 1 security group. However, we're going to create 2 security groups. One is for the application load balancer. And if we're adding the application load balancer, what we're going to do is modify the EC2 security group, which we haven't really touched that much. And we're going to disable traffic from over the internet. So historically, when I typed in this curl command right here, that's traffic over the internet into our EC2 instance. We're going to disable it because we only want people to be able to access our application via the load balancer. So first what we're going to do is come in here. Well, we're actually going to have to create a new security group. So we're going to select this option just here. I'm going to open it up inside of a new tab, and we're going to give it some names. Now for the name, I'm going to call it SG EC2-ALB, the security group for our EC2 instance application load balancer. Now the description of this particular application load balancer is to direct traffic from ALB to EC2 instance. That's pretty much what it does. And now down here, we're going to create some inbound rules. Now we are only going to add 1 inbound rule because we only have HTTP traffic. We don't have an SSL certificate. So for the inbound, we're going to add a rule, and it's going to be of type. We're going to scroll down and find HTTP. That's all good. And what we're going to do is select a source. We're going to go anywhere IPv4. And we're just going to allow it from any particular port. So that's absolutely fine, as long as it's the anywhere one. Now I think while we're in here, we're actually going to try add the HTTPS one. So what I'm going to do is just add a new rule, scroll down to make it HTTPS, and I'm just going to do the same thing, anywhere IPv4, and just leave these as the default values. Rules with the source of this, allow IP addresses to access your instance. That's what we want. So that is absolutely fine. And then what I'm going to do is scroll down, and just behind my head we have the ability to create this security group. Now it says we can't use that name, so let's just change it. So I'm going to call it security, or maybe AWS full course EC2 ALB, just so it's super clear. The clearer the better, if anything. So we're going to go ahead and create the security group. That's going to create that security group for us, and it's going to be applied to our application load balancer. because we're going to come back over to the tab and we are going to delete that security group, but we're going to refresh it and select it. So here I can see the AWS full course, select that and remove the default one. Now, for the listeners and routing, I actually lied a second ago. I said the security group was where we add the SSL certificate. Maybe I did, maybe I didn't. I actually can't remember 100%. This part just here is where we are only going to, at the moment, specify the HTTP protocol for listening and routing, because we don't currently have an SSL certificate. Now, if you do have an SSL certificate, so you've got a domain name for an HTTPS friendly address, add a listener tag. Sorry, don't add a listener tag. Add a listener and specify HTTPS and then do the same thing for your domain. However, we don't have it. You'll note, because I've enabled that option, I've got all this extra stuff just here. That's some extra config you would have to go through. It's pretty straightforward. You just provide your SSL certificate from wherever you got it. We don't have that for this tutorial. I'm just sticking with HTTP, so this is more than adequate. And what we're going to do in here, we've specified the protocol. We need to determine the target action. Now in here, what we're going to do, I've already got some because I've done this before. I'm going to create a target group because you won't have any. That's going to open us up in a new tab. And what I'm going to do is, for the configuration, I'm going to leave it on instances. I'm going to scroll down to the name. I'm going to go AWS full course. So AWS full course, ALB 80. That can be the target group name. The port is 80. The IP address is IPv4. We pretty much leave everything else as default. And here we have the health check. Now this is super important. If you do change the endpoint or the path for our health check, make sure you modify it here as well. That's very important. So we pretty much just give it a name, come down, and then at the bottom, we don't have to worry about the attributes or anything. That can stay the same. We don't have to worry about the tags, and we're going to hit next. Now just here, we're going to register the target. This is our new target, or basically it's our URL shortener EC2 instance. That's the target for our application load balancer group. For our application load balancer, that's super important. The target is the destination, so where the traffic gets directed to. We're going to include it as pending below. And now we have it as a target. The target is running. It's got the security groups, all that good information. We can click create the target group. So now we have a target group. It is going to currently be setting it up. So down here somewhere we should see that. And we can see just here that we have a tiny little health status that says the target group is not configured to receive traffic from the load balancer. Now this is important because this is part 2 of what we need to do. So we've created the target group for our application load balancer. That's absolutely fine. We can now select, let's just refresh that. We can select that AWS full course ALB 80. We can come down, and the last thing we can do is pretty much, we don't have to worry about any of these extra steps. You could add a tag if you want. I'm just going to click on create load balancer. Now it's going to provision our load balancer. We can see it's provisioning, however, we're not done yet. We need to come back over to our EC2 instance, and we need to look for our security groups. So if I scroll down, I swear the screen always looks different. Where are the security groups? Let's click on the security tab just here, and we can see we have the 2 security groups. Now if we open them both up, let's take a look at them both one at a time. This is the first one. This is the launch wizard. This is the one that is created when our application, when our EC2 instance is created. And if you look at let's click on this button here, edit inbound rules. It allows HTTP traffic and SSH traffic. Now I think we might have to come back and configure that at some point. Let's just have a look at the second one. Now this is our second security group rule, and it actually doesn't have any inbound rules. So we're just going to actually leave this one the way that it is, because this is for our relational database. So the one we want is the launch wizard example. Now just here, we currently allow HTTP traffic as an inbound rule from any directory. We also allow SSH traffic. Now SSH traffic is good. We always want to be able to SSH into our application from our IP address. However, we don't want traffic to be able to come in from absolutely anywhere, which is what this current rule is enabling. So what we're going to do is delete this rule, add a new one. It's still going to be HTTP. However, we're going to go from anywhere. Well, actually, no, we're going to go custom. And what we're going to do is when we select custom, if we come in here, we can search up our security group. So we should be able to select our AWS full course security group. And now that we've added that, what that's going to do is it's going to say, okay, you've got traffic from the security group, from our application load balancer. That's fine. We'll enable it. If it's not coming from the load balancer, then it's not going to be cool. So we're going to go ahead and save that rule. And now that I've saved that rule, I should be able to come back into my load balancer, and we should be able to check the health status. So currently it's provisioning. Let's go to the target group. We should be able to refresh this, and these health checks should be going out every 30 seconds. And we see here that the target is in an availability zone that is not enabled for the load balancer. Now the way that we fix that is we start off by identifying availability zones of our EC2 instance. So we come back over to our EC2 instance just here, come over to the details, and we should be able to find the availability zone. So what I did is I clicked on instances, and just in here we can see it's in the AP Southeast 2C. Now what we need to do after that is enable the correct availability zones for our load balancer. So we can come back into our load balancer. We are looking for our URL shortener ALB. So we can go ahead and click on that. And here we can see we have the issue. We can see that the Southeast 2C is not within the availability zones of our load balancer. And we can fix this very easily by just going actions. We can edit the subnets, and we can just select a third option to enable the AP Southeast 2C. Click on Save Changes. And now that we have saved our application load balancer, we can come back over to the target groups. We've added in that third option, and we can see that it is now healthy. So now that we have our application load balancer sitting in front of our application, it can successfully ping it, which means they can communicate. We will not be able to run our curl commands anymore. So if I come in here and try to copy this curl command and reuse it, I would expect it to get very much rejected. And we can see that I type it in and nothing happens. It's going to time out. And that's because I'm not allowed to. So our security rules are working effectively. What we now have to do is instead send the network request to our application load balancer, which is going to redirect them to our app. And it's actually pretty easy to do that. All we do is use this DNS name just here. And keep in mind, this is for HTTP because we don't have a domain name. So now instead of the IP address that I've used historically for my EC2 instance, we just use this DNS name. So with all of that done, I should be able to, we've found the ALB URL, the DNS name field. We can now basically create a modified version of our previous route. Well, actually, even better, let's just see if our new link works. So what I typed in here historically, this is our new domain. We go to the Go route, and let's see what our 3 keywords were. So the last time we did this, we used the keywords. I've got them saved in here. See if you can, in fact, remember. I think we must have used apple, vulture, and monkey. So let's copy them And we can actually confirm that they're in there. So what we might even do before we do that is I'm going to come back over to my EC2 instance, and I'm going to log in to my Postgres database. Let's see where that command is. Making sure that we set the username as URL shortener, and now that we have the database, we can also set that to URL shortener. We paste in the password. Let me copy that across. Paste in the password. I can do the /DT. We can see we have our table. I can type in the SQL command, select all from URL_shortener, : oh, that doesn't exist. We need it to be, the table is called URLs. So select all from URLs. And here we can see we actually have the apple, vulture, and monkey entry in our database. Our database has a collective of 3 entries, so I can copy that from here, and we would expect it to redirect us to our original URL. So I should be able to come to the end that says /go, paste on those keywords, hit enter, and we get redirected to example.com once again. So that URL is working. We could also confirm that it's working because if I come back to the load balancer and just once again copy that DNS name and paste that in here, we would expect to get back a 200 network response. We do in fact get back the OK. So that is working perfectly. So that is the next step complete, the application load balancer. You now have a scalable application. You could have loads of EC2 instances, and your load balancer is going to distribute the incoming network requests across them evenly. It's super great because if one EC2 instance crashes, your application load balancer will redistribute the traffic to the working ones. If you're redeploying your code even, it will redeploy it on them one by one. It's super clever like that. That way you always have application uptime. And with that officially added, we have our load balancer in front of our application. That officially draws us to the end of this introductory AWS course where we deployed a NodeJS, Postgres, and NGINX backend application. This is the fundamental of AWS. These are the most common AWS services that you'll probably encounter. There's 1,000,001 different AWS services that you can potentially use. However, the purpose of this course was to provide a gentle introduction to some of these services and get some pretty nifty deployment running, teach you how to SSH into these instances, configure everything within the AWS ecosystem, and hopefully just help you feel more confident and comfortable once again working with AWS because it's such an important service to be familiar with. Now, obviously, this is the introductory course. What are the extra steps that you could take to really take this to the next level? This would be like enterprise level production environments. Well, I've set up a couple, and you would be welcome to explore these if you really are trying to take your backend applications to the moon. That would be totally viable. And if you want, let me know in the comments down below if you would like a part 2 where I could explore all of these. I chose not to include them in this video because it just would have taken it from being an introductory AWS course to once again being slightly more intermediate to advanced. Anyway, the next step that I would recommend people take is to automate the relational database services backups into S3 with AWS Lambda functions and CloudWatch. So in here we have a couple of extra services. Now we are really lucky because we're using RDS. It already snapshots our database on a regular basis. So we have backups checked for the minute. However, hypothetically, if you did want to deploy another EC2 instance that was your own personalized Postgres EC2 instance and use that instead, then you would need to learn how to create regular backups in case you had any kind of database corruption or, error. And so the way that you would do it is you would set up an AWS Lambda function, which is just a cloud function. It's essentially just an API endpoint that you trigger, you add a trigger for. So every 24 hours, the trigger goes to hit that endpoint. The endpoint's like, right, I need to go and read all of the information from the database, then package it and upload it to an S3 bucket, which is just a cloud drive, a cloud storage environment. So there's some cool AWS services to become familiar with. After that, what you'd probably also look at adding is a CI/CD pipeline. So this is all about deployment. Now, deploying backend applications with a CI/CD pipeline is a little bit intricate, and you would integrate automated testing into that CI/CD pipeline. You would utilize GitHub Actions, so essentially it listens to commits to the main repo. So every time the main repo, or basically the code base, is modified via commits through Git or GitHub, GitHub Actions runs all of our tests. It packages our code inside an S3 bucket. So what I might do here is just add S3 and AWS code deploy. So it sends that production code to S3, and then AWS code deploy is triggered to read that code and then redeploy our EC2 instance. And that's an alternative to us having to SSH into it and basically re-pull the code down and rerun our start.sh script. Now, this step is totally not necessary, but once again, if you are looking to scale your application to the absolute moon, then that may be something that you would want to look into. After that, the next step would be to set up AWS CloudWatch for monitoring and optimization. So that's just a monitoring tool to, basically perform regular health checks on your application, make sure it's all up and running. And then finally, what you would look into is AWS auto scaling. So I have it here. And essentially how that works is you create a startup template for an EC2 instance. And then what AWS Autoscale does is, depending on the traffic or the load or the stress the stress that your application is under, how many incoming network requests, how much utility or resource is required to basically execute all of this code, respond to all of these incoming requests, AWS can pretty much calculate and scale up or down your application depending on the load and requirement. So that's a really cool thing to be aware of, and essentially it would take us from having one manually created AWS instance to having potentially 10 or 15, or a variable amount depending on the traffic. And each of these is spun up or spun down using that template that we would create. There's actually one last step you would probably look into for all of this, is you would look into the AWS JavaScript SDK. Now, what this is for is, it's essentially, for this whole process, we have used the AWS interface. We've done all the settings, we've clicked on all the different services, we've gone and managed all of the different settings for the respective services. However, you can do it all programmatically for free. Now, there are tools out there such as Terraform that essentially give you a syntax for doing this. However, Terraform kind of locks you in and constrains you, and you might even end up having to pay for it. And that is the same for equivalent services. However, the AWS JavaScript SDK is totally free. And so essentially we provision our entire application via or using JavaScript. And then when we run that, the code interfaces with AWS, and we do it all programmatically. So those are some super cool extra steps that you could take, as you continue to venture down into the AWS ecosystem. Once again, if that is something that you would like to see, let me know in the comments down below. Be sure to subscribe, like the video, and star the GitHub repo if you have enjoyed this full course. Thank you guys so much for watching. Love making this content for everybody. I hope it helps you feel more confident and comfortable using AWS. Slam AWS inside of your resume. Put down all the services that you have learned in this course inside of your resume. Feel free to take ownership of the code base even. It's pretty simple. You should be able to talk about in an interview. And yeah, thank you so much for watching. Catch you guys later. Peace. Learning to code? If so, be sure to check out the Learn to Code roadmap or dive straight in with these videos. That's a good one.